day by day. Sediments get laid down. They carry a record of what kind of environment they formed in, and so we can read that record.
Some of the elements that are present in sediments give us records, for example, of ancient water temperatures. Tells us something about the salinity of the ocean. Gives us some information about changes in the production of biological life with time. And that right now I think is the topic that's most interesting to most of us who work with sediments. I presume because that has the biggest impact on things that involve short-term climate changes and things of that nature.
The sedimentary record is our best indicator, I think, of what past climate has been. The evidence we get on land is very patchy, it's gappy, so we might miss warm events or cold events, whereas in the ocean, there are quite a few places where we have a continuous record, in some cases going back tens of millions of years. And what we find when we look at this is that there are major changes in the past. There are warm periods like today, there are cold periods, ice ages, that are related by and large to changes in the way that the Earth circulates around the sun. When we look back at these past, say, warm periods, we find that none of them are as warm as we are today. If we go back to the middle of the last century, fine, we were right where we ought to be for an interglacial or warm period. But in the last few decades, the temperature has moved into a set of values we've never seen before.
There apparently are critical combinations of climatic and oceanographic factors that trigger very rapid changes in the Earth's climate. And by rapid, perhaps changes that take place in a few decades. And that gives one pause because you wonder if, as changes are created in our climate system as a result of mankind, one that's well known is the change in carbon dioxide content in the atmosphere as a result of industrialization, the burning of fossil fuels. And the worry I think of is, are we approaching one of those criticals, at which time in a space of a couple of decades there will be major changes in the Earth's climate?
As oceanographers and other scientists attempt to predict future climate by reconstructing the past, they increasingly rely on sediments to provide critical information.
One of the ways that paleoceanographers have approached this problem of trying to interpret past climate is to look at the organisms that have been found within the sediment.
As long as there are biogenous materials within the terrigenous records around the continents, which there always are, we can read the history of the ocean quite well.
All organisms are controlled in their distribution by environmental factors. So there are essentially no organisms that are cosmopolitan in the real sense, that they exist everywhere. So when you look at the sediments and the animals that are found within the sediments, if you have representatives still living today, the same kinds of animals, you can make some inferences about what those environmental conditions were in the past that would allow that organism to live in that particular area.
Certain kinds of microscopic plants and animals like warm water, other ones like cool water, and by counting the proportions of the different types, we can actually measure the temperature of the water to within a couple of degrees centigrade. There are also chemical ways of doing it. For example, although the shells are made of calcium carbonate, they include a tiny amount of magnesium. The amount of magnesium depends directly on the temperature of the water that the shells formed in. So just by measuring the magnesium and calcium in the shells, we can get back a temperature.
The second is a little bit more sophisticated, which is to use the isotopes, oxygen isotopes found in the shells of those organisms, particularly the calcium carbonate types. And the isotope ratios are related to water temperature, so that if you do an analysis of the shells, you can theoretically get a temperature of the water at the time that organism lived.
What it really represents is a response of the organism to a particular temperature, the ease with which it can build its calcium carbonate, so on and so forth.
And that's been used extensively to try to map past climates. And the interesting thing about looking at sediments is that you can have a very long record. It could be millions of years. So we can get an idea of what past climates might have been, give us a much longer time interval to look at climatic changes. which is important when you start to look at issues about global warming, etc. The longer record that you have, the better your interpretations will be.